LeetCode problem 144, binary tree preorder traversal. Given the root of a binary tree, return the preorder traversal of its nodes values. Example 1, we're given the following input that looks like this. The output's going to be 1, 2 and 3. Example 2, we're given the following input that looks like this. The output's going to be 1, 2, 4, 5 and 3. We'll cover this example in our walkthrough. The approach that we're going to be taking is called the iterative preorder traversal. It uses the stack data structure, has a time complexity of O of n, a space complexity of O of h, where h is the height of the tree, and it will be the optimal solution to this problem. Now let's walk through the example, where the root is 1, and then the child nodes are 2, 3, 4 and 5. Step 1, declare two variables, stack and result. Stack will be an empty stack and result will be an empty array. Handle an edge case, check if the root equals null, returning the result if it does. Step 2, push root onto the stack. Step 3, while stack is not empty, pop the node off the stack as current node, load the current node's value into the result array, and then push the right child node, then the left child node onto the stack if it's not null. So we push the one node onto the stack, we check if the stack is not empty, which it's not, we then pop the one node off the stack and set that to the current node. We then add the value of the one node to the result, so we add 1 to the result. Check if it has a right hand child, which it does, which we can see is the 3 node. So then push the 3 node to the stack. Check if the current node has a left node, which it does, which is the 2 node. So push the 2 node to the stack, and then we'll check if the stack is not empty, which it's not. Pop the stack, so the current node is now equal to the 2 node. Add 2, the current value of the node, to the result. Check if the 2 node has a right child, which it does, which is the 5 node. So push the 5 node to the stack. Do the same for the left node. We can see it does have a left node, which is the 4 node. So push the 4 node to the stack. And then while the stack is not empty, we can see it's not empty. Pop the stack, so the current node is now the 4 node. Add the value of the 4 node to the result, so add 4 to the result. Check if the 4 node has a right child, it does not. Check if it has a left child, it does not. And then we check if the stack is not empty again, which it's not. Pop the stack, so we know the current node is the 5 node. Add the value of the 5 node, which is 5, to the result. Check if the 5 node has a right hand child, it does not. Check on the left, there is no left child. The stack is still not empty, so we need to pop the stack, giving us the current node of the 3. So the current node is a 3 node. Add the value of the 3 node to the result, so add 3 to the result. Check if the current node has a right child, it does not. Check if it has a left child, it does not. And then we'll check if the stack is not empty, which we can see the stack is empty, so step 4, return result. The result is 1, 2, 4, 5 and 3, which is exactly what we expected. It's as easy as that. Why not pause the video and try to implement a solution yourself? If not, stay tuned for my solution next. LeetCode problem 144, binary tree preorder traversal in JavaScript. Given the root of a binary tree, return the preorder traversal of its nodes values. Example 1, we're given this input, which looks like this, and the output is going to be 1, 2 and 3. So 1, 2 and then 3. Example 2, we're given this input. Visually, this is what it looks like here. Now the output, what preorder traversal is you firstly want to load the node, so the root. So you'll load one. You load one. Then you go to the left hand side. So you'll then, this becomes the root of this subtree. So you'll load the 2. Then you go to the left. You would load the 4. You can see there is no left and there is no right. So then we go over to the right hand side. We'll load the 5. Then we'll go to the left, which is the 6. There's no child nodes to this. We've already loaded the 5, so we get to the 7. Then we've loaded all of this side of the tree, so we now need to go to the right hand side. We'll load the 3. You can see there's nothing on the left, so we then go to the 8. We then load the 9. And that is exactly what the output was there. Cool. So that's what preorder traversal is. Then example 3, we've got the root is equal to null. So we've got basically an empty tree. In that scenario, we just want to return an empty array. And then example 4, we are given a single node tree, which is basically you just want to return the value of that node. So in terms of edge cases, I think that the examples sort of show 3 edge cases here. The first one that I'll discuss is example 3, where you are given an empty tree. So root is equal to null. In that scenario, you've got to return a empty array. You can't return null, because if you return null, then the return type is incorrect. You see this expects an array of numbers, so you've got to basically return an empty array. That's what your solution has to do to pass that edge case. Example 4. This is another edge case, which is where you're given a single node. It's pretty easy to handle that. You just return the value of that node that you've been given. And then the final edge case is where you have got nodes in the tree where they have either a left or a right, but not both. So you can see node 1 does not have a left child, but it does have a right child. And you can see that node 2 does have a left child, but does not have a right child. So this is another edge case that your solution needs to be able to handle. Cool. So let's get into it. So the first thing that we're going to do is we're going to declare a couple of variables. So we'll declare a stack, and we'll set that equal to an empty array, or an empty stack. We then need the result, which again we'll set that equal to an empty array. And then the first thing in terms of logic that we want to do is we want to check if root is equal to null. Then we basically want to return result, which is going to handle this edge case. So it's going to then obviously return a result, which is an empty array, which is the output that example 3 demonstrates. Cool. And then what we want to do is we want to say while, what we want to do first is we want to push root onto the stack. So stack.push root. And then we say while stack stack.length is greater than 0. Then what we want to do is we want to pop the stack. So let current node equal to stack.pop. And we then want to add the value of the current node to the result. So result.push current node.val. And then we want to check if, because we obviously want to load the left node into the result before the right node. So because a stack, so let me write the code. So if current node dot write, then we want to push it onto the stack dot push current node. dot right. And we want to do the same for the left, so if current node dot right dot left, sorry, left. Then we set stack dot push current node dot right left, sorry. So the reason that we're doing the right hand side first and then the left hand side is because when we come back and we pop the stack here, we want to process the left hand side first. So if we're pushing the right hand side on before the left hand side, then the next node that we pop off is going to be the left one, which is exactly what we want. Cool. Now that's all of the logic that we need to do inside of the while loop. Once the stack.length is equal to 0, it means that we've iterated over every single node in the list. Sorry, in the tree. And then finally, we just want to return the result. See if that runs. It does. Then we'll submit it, see if it passes the edge cases, which it does. Excellent. So in terms of runtime, it says that it beats 100%. And in terms of the memory, it says it beats 6.22%. I can tell you that the runtime complexity of this solution is O of n, and the space complexity is O of h, h being the height of the tree. This is the optimal solution to this problem, and I hope that this has clarified the problem and the solution for you. If you could please click like if you like the video, that'd be hugely appreciated. And if you could click subscribe, that's going to massively help me and the channel out and help me to get these video tutorials out to a wider audience. If there's anything that you can think I can improve on, or you've got any further questions or any videos that you'd like me to produce in the future, please leave them in the comments below and I will get back to you. Thank you very much for watching and good luck with your coding.